then combinations and permutation, that is concatenations, pulverizations. A number of commentaries has been written on the work of Lilavati. I am mentioning very few. Parmeshwara wrote around 1430, Buddhi Vilasini of Ganesha, Surya Das and Munishwara wrote in 1635, and many results which were given in verse form without proof. Some of them have been proved by these commentators. Further, it has been adopted in different regions, in different regional languages. Commentaries have been written. That shows its popularity. 3 Persian translations are also known. Abul Faidi, one of the member of in the court of Akbar, at the instruction of Emperor Akbar, he has translated it in Persian, and he has he has also given a story which is a legend mentioning that Lilavati is the daughter of Bhaskaracharya, and since Bhaskaracharya was a great astrologer also, he has seen his her horoscope and casted that she can get married only when a particular muhurta, lagna which we call, a special day and hour of that day, if that marriage ceremony is performed, then the marriage will be successful. And for that he has designed a water clock, a cup with a hole at the bottom is placed in a water vessel, and the moment the cup will sink, the auspicious time will be there. So, everything was set by curiosity. Lilavati just wanted to see, and unfortunately a pearl from her clothes fell into that, and that cup did not sink at that moment, and the lucky hour has passed. And see, this is, in fact, there is no authenticated evidence even in Lilavati that Lilavati is the daughter of Bhaskaracharya, but it is mentioned by Faidi in his commentary, in his translation. Then H.C. Colebrook translated this in English in 1870. So, this shows the popularity of this book, and it served as a textbook over 800 years in various schools, and even I think in many of the Sanskrit colleges, Siddhanta Shiromani is taught nowadays also. So, many translations and commentaries by various scholars. The next is the next part is algebra, and he has written Purva Proktam Vyaktam Avyakt Bijam Praya Prasna No Binaya Vyakta Yukta. We earlier discussed explicit calculations which are rooted in the analysis of indeterminate, the unmanifested numbers. However, usually the problems cannot be solved completely without the trick of indeterminates by people with weak intellect. So, I will also explain the use of the indeterminates. So, that is what he has given in algebra. He has written for his Bijganita, which comprise various rules, examples and problems, 6 operations with positive, negative numbers. All are written in verse forms. So, I am not mentioning all the verses. Few selected one I will be mentioning. Arithmetic of 0 and surds, the indeterminate equation of first order and second order, the Berg Prakriti, the square natured problems, that is, he has given one of his own method, and the previous Brahmagupta's method he has generalized, that is called cyclic or Chakrawal method. Navankura, These are the commentaries. Again, this was also been studied by various scholars, and commentaries has been given by elaboration of his work. The last two parts are dedicated to astronomy and studies about planetary motion and astronomy. Goladhyaya explains in detail the theoretical aspects of astronomy, gives latitude and longitudes of planets, how to determine. There are methods in the various forms, eclipse calculations, spherical trigonometry, and large number of instruments are given in that Yantra Adhyaya. So, in fact, this around I think 900 something verses are there in these two chapters. So, I have not focused on them, I specifically focused on the first two part. Some formally methods, illustrated problems which I feel I should give in the presentation. So, this is the formula which we use regarding the type of number of permutations of n things, of which R1 are of one kind, R2 of another kind, and this is the formula first given by Bhaskaracharya only. See how he has the problem is pasang kusahi damru kapal shule khadwag shakti sarchap yuktar bhuvanti अन्योन्य हस्त कलितय कति मूर्ति भेदा संभो हरेर भी गदा सिर सरोज संख्य. This is a question. Say Lord Shiva holds 10 different weapons in his 10 hands. He is considered to be having 5 heads. These are this mean in one hand a trap, a goat, a snake, a drum. In this way, find the number of different Shiva idols. This is a question of permutation. So, this is the answer will be 10 factorial. Next, similarly solve problems of Vishnu idols. Vishnu is Chaturbhuj Swarup, and in his 4 hands a mace, a disc, a lotus and a conch. And how many idols can be there? That is 4 factorial. 4 factorial is coming out to be 24, and 24 avatara of Vishnu. So, this is how he has given problems. He has related mathematics with nature, the objects of nature. He has used mountains, rivers, clouds, lotus, birds, animals, so that whoever is, even one who is not curious about mathematics, once he go through it, he can create interest in that. So, that is why it has served as a textbook for 8 centuries. About 0, he has written Badhato Vyat Khasyam, Kha is termed for 0, Kham Khen Ghate, mean a 0 results when a number is multiplied by 0. This is what he has given a rule, 0 plus 0 is 0, 0 into 0 is 0. And for infinity, he said 1, he was the first one. It is recorded by some of the historians. I have given at the end the references. Any number, any non-zero number divided by 0 becomes khahara. That is infinity, which we call. So, this is again the rules regarding 0. 0 plus 0 is 0. Its square is 0, number divided by 0 becomes khahara, and multiplied 0 is 0, but this khaguna should not be paid attention to during remaining process. If you have a number x into 0 upon y into 0, it should not be paid attention to, mean it is khahara is infinity, khaguna is, in that way it is just, see there is no variation in this khahara by adding. This is the property of infinity. I think that is in the next slide I will be going to show you. So, he said infinity plus finite is infinity by adding or subtracting, just as the infinite stable Brahma is not affected by numerous living beings entering or leaving it at the time of dissolution or creation of the world. So, that is infinity plus finite is infinity. So, this is what he has established. If certain number is, this is what I want to tell you, if a certain number is multiplied by 0 and divided by 0, the answer should not be as either 0 or infinity. It should be retained as is for further calculations. In this sloka, that is the translation of that. This simply means x multiplied with 0, and he has given it to be x divided by y. And this can be interpreted by using modern notion of limit. Limit, if I just replace 0 by h, which is approaching towards 0, so limit x multiplied by h, so it comes out to be, it is easy to understand. So, the idea of the infinite small calculus was there, it authenticates that. Another one problem I am discussing, a certain number is multiplied by 0 and added to half of the result. It is in fact in the stanza form, I think it's no, it's not there. If the sum so obtained is first multiplied by 3 and then divided by 0, the result is 63. Find the original number. So, it is basically obtained by reverse process given by Bhaskaracharya. For the, he has given this way, x multiplied by 0 plus half of the number, that is x into 0, this total is multiplied by 3 and the resultant is divided by 0. Will, if it is coming out to be 63, what is the value of x? And this, if we just use the modern notion, so you can see with the help of limit, so the answer will be, we can easily compute the answer, that is h will cancel out and you can compute the answer. So, it is computable. Otherwise, if we keep the first one, it becomes indeterminate. Another important method he has described, that is the method of pulverization, Kuttak. This is the first order equation, indeterminate equation. Find the integral solutions for this equation. This is the exactly the equation which he has given in his Leelavati. 100, it is actually transformed into this, it is in verse form. 100 times x minus 63y is plus minus 90, or left side is plus minus, so you can have that. So, I have taken just one. How to solve this? Dividend is 100, he has given the rules for that. There are 4 stanza which are describing the rule for solving this. Divisor is 63, and if HCF is 1, this is said to be in improper form, and if it is HCF is not 1, then we just get out the common factor and that will be cancelled out, and then we transform this to in this form, and then we go on dividing. 100 is divided by 63, quotient is 1, remainder is 37, then 37 is dividing 63, quotient is 1, 37, 1 times 37, remainder becomes 1, then 26 divides 37, quotient is 1, and in this way we can write quotients on the last column and the first one accordingly. 4 2s are 8 and 11 minus 8 is 3. 2 is the quotient and 3 is at the bottom of 11 is the remainder. So, in this way then we can create the table, rule is given, the rules are given there for this, and at the end we get at the top we just find 90 into 2 plus 90, that is the number coming below that, that becomes 270 can be expressed as 90 plus into 2 plus 90, then 630 is 270 times this plus this. So, this is the way he has given, and finally 2630, and we find we divide it by that 100x. So, dividing it by 100, remainder is 30. So, y is taken to be 30, and the next just preceding 2430, there was 1530, that is divided by 63, which is coefficient of y, and this ultimately satisfies the equation, and you get the infinite solution which are in the integral form. So, this is how the method has been discussed. Further, he has elaborated a method for biquadratic equations at that time. This is the problem. Ko rasir dishwanti chunno rasi varga yuto hatay. Dvabhyam teno tino rasi vargo yuto bhavit. Ruponam badatam rasi vetsi vij kriyam yadi. So, this can be transformed into this equation. This is the equation which has been written in the verse, and he has formulated. So, making the use of perfect squares and then simplifying, the answer is 11. This is one well known Pell's problem. In fact, this is the problem which has stormed the brains of various analysts. Even I think this is a very historical problem, particularly the second one given in the B part, that was posed as a challenge by Fermat to Wallis and Brouwer, and even Lagrange, Euler and Lagrange have given a solution for that I will be. So, Bhaskaracharya given a method for that. I am not mentioning the method here, and the solution is, the minimum possible solution is in 9 and 10 digits for the second problem. That is, you can see the last one, x is 1766, this is the minimum solution. The first solution, then the solution can be, this is the first term of the solution series in increasing order. This was a challenging problem by, which has posed a challenge as this to Brouwer and Wallis, and this Chakrawal method, it is mentioned, this method is mentioned in these verses of Bijganita, and Euler-Lagrange algorithm, they have given later a method for finding this, but it was found by some of the scholars that the method given by Bhaskaracharya for particularly that when multiplier is 61, that is computed in very few steps, and the method of Lagrange and Euler, that takes, because in their Chakrawal method many things have been excluded. So, this is the notion of from Goladhyaya I have just mentioned. He obtained the Tatkalik Gati, the instantaneous velocity, which uses the modern differential calculus, which have been considered to be invented by Leibniz and Newton. So, the difference of two sines is equal to the product of the elements of the radius and cosines of the semi diameter. So, you can just see sin x minus sin y, x and y are the anomalies of the planets at two different positions after certain interval of time. So, delta sin x is almost this. So, this is an idea of infinite small calculus. Yatra grahasya param phalam tat yatraiva gati phalam bhaven bhavitavyam, where the motion of the planet is stationary, the value of the planet's motion is extremum. Mean this is the condition for f dash x is 0. So, this just reminds me of and many historians of the present Rolle's theorem. He was well aware of the concepts of limit and differential calculus centuries before Newton and Leibniz. This was also given by and few remarks. This is in the inscription of one inscription found in the temple Sarjavadi. Triumphant is the illustrious Bhaskaracharya, whose feats are revered by both the wise and the learned. A poet endowed with fame and religious merit, he is like the crest on a peacock. This is mentioned in the book, which Professor Kanan also mentioned, that is by Joseph. He was Asto Vyakaranani Satch Visajam Vyachast Cha Ta Sahita Sat Tarkani Ganitani Panch Chaturo Vedan Dhite Smaya Ratnanam Tritayam Dvayam Ch Bubudhe Mimansaru Rantare Sad Brahmaekam Gad Bodh Mahima Swasya Kavir Bhaskara. This is the glory of the great Bhaskara. So with this I conclude.
Thank you, Dr. Bhagwati. Can we take a couple of questions for Dr. Bhagwati, please? Yes.
Sorry.
Thank you very much for this very nice talk. There's one thing that struck me, and that is that here you have mathematical texts which are written as poetry.
Yeah.
That's, according to me, unique. You don't find that anywhere else. And the question is, why is it? Why is it so? Why did they do it in this way? Was other knowledge also represented in the form of poetry, or was it to make it easier to remember?
Yeah, this is the tradition of India. If we just go back to our texts, Sahitaj, at that time
so it is an Indian tradition to do it in this way.
Yeah, that was the tradition. It started right from the very beginning.
Okay.
Our Vedas, they are in verses.
Okay.
And Ramayana, up to that also. I mean, those, even if they are not related to mathematics,
were also written in the form of poetry. Okay, thank you. That answers my question. Thank you.
Any more questions left? Yeah.
Why do you think that this knowledge is sidelined or not in mainstream, and we are rediscovering after it came to our classrooms? Any thoughts on that?
Yeah, it's because first thing is the knowledge that our seers treasured, that was not recorded very well in the history of mathematics. The credit, whatever be the reasons, but these things have been, even in the many historians, these have written, they have assumed without any solid evidence, might be there is transference of knowledge from Babylonian mathematics or Greek mathematics to Indian. And the another thing is this, in fact, now our NCERT books, many of our NCERT which are written now, they are giving the details of Indian mathematicians, their contributions. Even that Bodhayan Apastambh Prameya is there written in that NCERT text of our schools. So it will be really and inspiring and to feel proud of the things if it can be included more in that form. So from wherever we get chance, in our even when I go to a class, so I start the things. The moment one say hello, so I say, what's the use of mathematics in this? So first you have to use the numbers. Then there is signal. Signal is wave. Wave is differential equations. Then is transformation. That is, the signal is digitized. There is a mapping, fx equal to something. Then there is inversion. And then comes we think of cryptography. the prime number theorems which were given by, in fact, great Ramanujan. So, wherever we, particularly those who are involved in teaching professions, they expose the things, then I think it will be an improving one.
We could take one more last question here, Dr. Bhagwati.
Yeah.
Dear Professor, it seems like, this formulation that has been now being represented in formulas, if this was not being formulated in the Western countries, our poetic pieces would not have give answer.
Till my, I think to the best of my knowledge and whatever I have studied in the various literature relating to history of mathematics of India and abroad, so I am not aware of any such type of poetic relationship with mathematics.
Yeah, so it seems like, something that has been happened in the East that has been proved by the West. Just like consciousness we have in the East, but now we're waiting for the formulation from the West. But there is some correlation, but I should say that whatever the formula that has been generalized coming from the Western education was not being formulated till today, our poetic formula that has been equivalent would not have been proved. This is what I would like to say.
No, one thing. So you mean the poetic formula that is given by, suppose, Bhaskaracharya. I have just quoted that Berg Prakriti equation, Chakrawal method, that was given in 1150, and this was posed as a problem by Fermat in 17th century. So, but that was in different way, that is in the prose form, that is a special case. So they have maybe from there that they have generalized the idea, and then they just want to search for that.
Okay, thank you so much, Dr. Bhagwati. Now we'd like to call upon Dr. Christoph Bensmuller to please give a token of appreciation to the speakers of this session. So first, a token of appreciation for Dr. Bhagwati. Round of applause. Next, we'd like to ask Dr. Christoph to please give a token of appreciation to Ms. Jordan Bergmans, please. Can we have a photo with all of you, please, on stage? Yes. Thank you so much.
Thank you so much. So now it's time for the refreshment. You can go out and refresh your mind, and after that we have a workshop on holistic living and practical spirituality for all the students over there. And thank you so much, and enjoy your refreshment. Thank you.